my normal weekly ones. My name is Tara Lyons, and I'm going to talk for a while today about Leaving Cert Chemistry and answer questions that you may have. So I'll talk on for about 20 minutes or so, and then I'll stop and see if anybody has any questions in the chat, and I'll pick a few of them and answer whatever it is you want. Continue on, then show you something maybe that you might find useful for your Leaving Cert, and at the end we can chat again or answer any questions or queries that you have with regards to chemistry. So first of all, would anybody be able to give me a thumbs up or a, what you call it, a little message to say that you're able to hear me okay? Yeah, oh, loads of thumbs up there. That's super. All right, so delighted to hear that. So I'm going to share my screen with you guys, and what you call it, when I share my screen, you'll see I'll be using both my screen from my computer, and I'll be moving on to kind of a document reader and going through maybe a couple of calculations or something like that with you later on. So if you can't see what I'm doing, once I change over, sometimes I can't see what's happening and you can't put microphones on. So anyway, we'll sort it out, and hopefully everything will be good. So I am going to talk to you first of all about, I'm sure, the layout of the paper, but I want to talk to you about the layout of the paper and how you are going to, what you call it, maximize your chances of maximizing your grades come June. This is what I have, the advice that I have given to all of my students for many, many years now at this stage. And folks, in terms of the results that I get from my students, it definitely 100% works. So somebody has a hand up. You want to type in a message? The recording will be uploaded. I think you will, yeah, you'll have access to the recording. All right, okay. What you call it, for this thing is you've signed up to come here as well. Okay, all right, thanks a million. So going to share my screen, and let's have a look at this. Access to whatever I'm talking about, I will be giving you that, what you call it, also. Okay, so here we go. So the first thing that I want to share with you here is the actual layout of the exam paper and the various questions that I would suggest that you would attempt in the exam. So you're going to get 11 questions on your exam paper. You can answer any 8 questions you like, any 8. So you are not restricted, like previously before COVID, to having to answer a certain number out of each section. Any 8 questions you like, and all questions carry equal marks, so it really doesn't matter which ones that you choose. Now, question 1 is going to be on volumetric analysis. You have 8 experiments on volumetric analysis, and it's not 8 completely different experiments, folks, right? There's a massive amount of overlap here. So the procedures for using your equipment, your pipette, your burette, your conical flask, the way to prepare a solution, which has been asked 22 out of the last 24 years, those procedures are the same year in, year out. So regardless of whether you get an iron tablet redox experiment question, or you get an acid-base question on water of crystallization, the procedure for using the equipment is the same year in, year out, and roughly 1/3 of the marks for question 1 will go for that. Now, that's a roughly 1/3. Could be a little bit more, could be a little bit less, but if we hit on 1/3 of the marks for that, then we know that we have to have those procedures prepared. Calculations will also be worth roughly 1/3 of the marks for the question. Roughly 1/3 of the marks. And every question has its own unique calculation. So the type of calculation that you're going to do to work out the percentage of iron in iron tablets, and I've mentioned iron twice now purely because it hasn't been asked for a very, very long time. So, with regards to the percentage of iron in iron tablets, that's going to be different to working out the value of X in a water of crystallization, which also is another experiment that hasn't been asked for quite a while. So the thing is that you practice these calculations, you learn these procedures, you sit down and you learn them. And I would suggest, if you're concerned, are you learning them correctly or not, I would suggest you use your marking schemes. The marking schemes have the correct answers for everything laid out for you. So if you want to know what was I supposed to say for how to rinse a pipette, do you know what I mean? Then you check the marking scheme in that question and you'll see exactly what it is and you learn that. Now, with question one, every question, or every experiment, I should say, has questions that are unique to that experiment. And they want, you know what I mean, to ask you those unique questions as well for the remaining 1/3 of the marks. Right? So things like, you know, if you're using an indicator, what indicator are you using in an acid-base titration? Will it be methyl orange? Will it be phenolphthalein? What color change that indicator is going to give you in the experiment? If you're not using an indicator, what are the color changes, we'll say, in potassium manganate 7 experiments? And, you know, if you're using iodine and thiosulfate, the fact that your indicator is starch. Massive amount of overlap. You are not learning 8 experiments. You're learning, you know, even half that or a third of that amount, right, of material, because 2/3 of every question is an overlap. I would then go on to question 2, organic chemistry. You have 7 experiments. No overlap here, folks. No organic chemistry experiment is the same as any other organic chemistry experiment, and they have nothing in common with each other. There might be a link between a few of them. For example, if we prepare benzoic acid, we could be asked to determine the melting point or to recrystallize that benzoic acid. So there are links between them, but they're all completely individual. But as I keep saying to my students, there are 7 possibilities, not 17, not 107, 7 possible experiments. So you learn them, you sit down, you go through them. There's a limited number of questions that you can be asked on them, and you learn those. So for example, if it is the preparation of ethene, do I know the equation for the preparation? Do I know the safety procedures involved in that? Do I know that ethene is unsaturated? How do I test for it? If you look at any preparation of ethene question, it is the same material examined, re-examined, year in, year out. Now, preparation of ethene comes up an awful lot. You know, same thing. Preparation of soap has been asked 5 times in the last 24 years. And apart from 1 year where instead of using animal fat to make soap, they used coconut oil, all right, to make it, it is the same questions. When you make soap, every question you look at, why do you reflux? 3-part answer to that. Speed up the rate of the reaction to ensure a full base hydrolysis reaction occurs without losing any volatile material. So what I'm saying to you there is you sit down, you learn your 7 experiments. Now, the diagnostic tests for unsaturation, for the presence of an aldehyde and for carboxylic acid also appear in question 2. And there will be at least one of those every single year without fail. So I would be going, I'm going to prepare question 1. I'm going to prepare question 2. That's 15 experiments. 15 experiments out of 27. So just a little over half. And you've got 25% of your paper on 15 experiments. If you did nothing else, you have 25%, possibly more than that, because there's going to be bits of those experiments popping up in section B as well. Now, question 3, you've got another 12 experiments here, and they're usually on rates of reaction, water, the heat of reaction from your, fuels chapter, determining relative molecular mass of a volatile liquid, which hasn't been up for a while, so it's due a twist, I would imagine, pretty soon, so maybe this year, and test for anions and flame tests pop up in that as well. You have to be aware that twice in the last 24 years, 2004 and 2011, question 3 has been a second organic chemistry experiment. So the reason why they can do that is, as I've mentioned, all the organic experiments are different, so they can give a question 2 on an organic experiment and a question 3 on another one, because there's going to be no overlap between those. So my advice is that you definitely prepare question 1 and 2. Right? There'll be a few experiments that you'll probably be happy enough with for question 3. If they come up, that's great. If they don't, you've got question 1 and 2 prepared. 15 questions is going to get you 25%. Question 3 is 15 experiments is going to get you 25%. Question 3 is 12 experiments. It's almost the same number, but it's only going to get you 12.5%. So I'd be going for question 1 and 2. And again, this is something that I have discussed with students over the years, and they have followed and taken this advice, and they have been very, very happy that they did so. Question 4, folks, on your paper is always 12 short questions, and your best 8 are marked. Right, okay, questions will come from all part of the syllabus. The last part is in whatever option your school is going to choose to do. Right, so that is question 4, the whole course. Now, if you read any chief examiner's report on question 4, they will tell you that it is not the best answered question on the paper, but it is one of the most popular questions to be answered on the paper. It's usually the second or third most popular question on any year. The reason why it's not the best answered question, folks, is because people do not practice it. They mistakenly think that short means easy, right? Short questions means that they're looking for short, precise answers, right? No room for waffling, no room for, do you know what I mean, making stuff up as you go along. If it's a colour change, you got to know the colour change. If it's an oxidation number, you've got to know your rules and which ones to apply. If it's a definition, did you learn your definition? Or are you, do you know what I mean, trying to remember the odd word from class time? Chances are that's not going to get you very marks. Question 4 needs to be practiced. It's a question that I would test my students on. I'd give them at least 4 question 4 tests, if not 5, in 6th year, purely on question 4. Question 5 is atomic theory. Now, folks, that's a long section of your course. That's your periodic table. It's your history of the periodic table. It's all about what you call it, the atomic radius, ionization energy, electronegativity, bonding. It's radioactivity. But it is what you do mostly in 5th year. So it tends to be the material that you cover at the start. So students tend to know it reasonably well. Now, my advice, if it were a bonding question, is you want to be pretty confident about your bonding. Okay, a lot of people think they are, but you've got 7 types of bonding on a Leaving Cert paper, folks. 7 types. And if you pick the wrong one, you're in trouble. So you really would have to have the confidence to know what the intramolecular bonding is going to be. Is it ionic, pure covalent, polar covalent, you know what I mean, dative covalent, or are they talking to me about intermolecular bonding, which is your van der Waals forces, your dipole-dipole, and hydrogen bonds. So my only, I suppose, warning here for question 5 from my experience with students is when the question is on bonding, people think they know about bonding because you did a little bit in junior cert, but it's nothing in comparison to what you've done here. So again, practice questions, look at marking schemes, make that decision. Question 6 is another question I would plug a lot. It is the most popular question on the paper. It's on fuels and heats of reaction. So that is your crude oil, your natural gas, fractional distillation of crude oil, petrol, what makes a good quality, what makes a poor quality petrol, and how do you improve the quality of petrol by various reforming methods and additives, and then a little Hess's law calculation. So question 6, most popular question, really well answered, all right, okay, usually. It is actually the least amount of material that you need to learn in order to do a full question. So hence it is one of the most popular questions on the course. Question 7 can be on anything, but about 7 out of every 10 years it's on acids, bases, and pHs, and the other 3 years it's usually on equilibrium. So it's one of those 2 usually, right? So 70% of the time, acids, bases, and pH calculations, and then the other 30% of the time, it's generally on chemical equilibrium. That is, if chemical equilibrium isn't in question 8 or 9. Question 8 or 9 is always the general organic chemistry question. That's where you need to know all organic, right? Okay, for that. So that's all you're drawing your molecules, you're naming your molecules, planar carbon, tetrahedral carbon, your reactions, the reagents in order to do the conversions. My one piece of advice with organic at this stage of the year, folks, is if you can't draw and name the molecules, that's where you start. It's very hard to do well in organic if you don't know the names and how to draw your molecules. So general organic chemistry, my students, I encourage them to do that question, but I do test them a lot in organic chemistry. All right, okay. I do push organic a lot throughout the 2 years. I started kind of around after Easter, or after Christmas, I should say, in fifth year. Do you know what I mean? I do about half of what needs to be done in fifth year, and then we finish it off in sixth year. But because organic is worth so many marks on the paper, it would be madness to ignore it. Without organic chemistry, you have little or no choice, folks. So you got to learn to love organic. Question 8 or 9 is often equilibrium. If that hasn't popped up in question 7, it could be water. It could be, do you know what I mean? Yeah, right. So water, equilibrium, something, do you know what I mean, along those lines. Question 10 has 3 parts, you choose 2. Question 4 has 4 parts, you choose 2. All syllabus coming up there. And in question 10 or 11, there'll be more organic and there will be more atomic theory. Half a question more on organic, half a question more on atomic theory. Then, folks, after you know your volumetric for question 1, your organic for question 6, question 8 or 9, and the half a question, question 2, and the half a question in question 10 or 11. After you know all of those, the next thing is water, chemical equilibrium, and rates of reaction. There will be a full question and a half a question minimum on that. So here's what I'm saying. Prepare question 1, 2, 5, 6, and your general organic, which is question 8 or 9. Do your equilibrium of water and your rates, and you now have 6 questions prepared before you walk in June. You get those pre-prepared, right? You do every question and every possibility on those, of which there is plenty of time for you to do, folks. Believe me, there is plenty of time to do this, right? So I'm not giving you advice and there's only a week or two, do you know what I mean, left, right? Lots of time between now and your exam to get this done. That's 75%. That's a H3, right? And then all you have to do is choose 2 questions out of 5. And remember, within those 5 questions, you're looking at question 4, question 10, and question 11, and they all have internal choice within them. So you'll have no problem choosing another 2 questions to bring your grade up. But if you want to do this, if you know what I mean, you want to maximize your grade, this is how I 100% am confident will get you there. Preparing certain questions on the paper. Now, it's not carved in stone that you're going to do those questions, right? Okay, so, you know, there will be choice on it, but if you walk in with a plan, chances are it'll go well for you. If there's no plan, folks, chances are you're going to be frantically trying to swim around and, you know what I mean, trying to pick a question here, pick a question there, and so on. Maybe that's the type of thing that has happened in your mock paper. Maybe you were, do you know what I mean, jumping around from, do you know what I mean, section to section. And that then meant that you didn't, do you know what I mean, do as well as you thought you would, right? Think about preparation, right? That's the most important thing, preparing those. Anybody, any questions on that now before I move on, folks? Anybody, anything that they want to type in to the chat in order to ask me a question? We good? Are we? Yeah, we're okay with that much? Okay, does oxidation and reduction come up often? Yeah, it's there in some form every year, right? If it's going to come up, okay, oxidation and reduction as a question on its own, right, it will only ever be a half a question. So it might pop up on question 10 or 11. So the ones with the 3 parts and the 4 parts, the last ones. Now, you do have to know oxidation and reduction or the fundamentals of it for question 1. You know, 5 of your 8 experiments are redox. So you have to understand the change in oxidation numbers, especially we'll say with potassium manganate 7 titrations, going from +7 to +4 to +2. Do you know what I mean? So, you know, oxidation and reduction like acids and bases is a bit of what I call a foundation chapter. They're never going to ask you a full question on it, but it's going to pop up and be part of your understanding in other areas of the course, and especially with electrochemistry. Every single reaction type in electrochemistry, be it electrolysis, be it displacement reactions, all of those involve redox, so it can pop up with that. Organic chemistry experiments twice in the last 24 years have come up in question 3. If you look at 2004 and 2011, you've had an organic question 2 and a question 3. Do I think there'll be a rates graph? I would be mad not to expect a rates graph. Okay, all right, for that particular question that somebody asked. Do you know what I mean? If I go into the exam with my fingers and toes crossed, hoping there won't be a rates graph, right? Okay, that's me taking a massive gamble. And, graph questions, again, need to be practiced. Do you know what I mean? You've got to get your calibration of your axis right for 3 marks. You've got to make sure that you have your axes labeled and the units involved for another 3 to 6 marks. And then plotting your points correctly is another 3 marks. So you can actually get half marks on a graph before you ever draw any graph, as in ever plot any point. So your calibration of your axis, making sure that you have the correct, do you know what I mean, distances between your, what you call it, the values on the x and the y axis, and also then making sure that you label both axes and give the units for it. So yes, it's unusual if there isn't a rates of reaction graph. When I say question 3 could be organic, do I mean it could be a full organic question or part? Full. Again, 2004, 2011, have a look at question 3. You see, because you've got techniques like chromatography, recrystallization, and steam distillation. So there's 3 techniques for organic chemistry experiments. And then you've got 4 preparations: ethene, ethyne, soap, and benzoic acid. And you see, again, you could have question 2 on a preparation. You could have question 3 on a technique. And there's absolutely no overlap whatsoever. And that's what happened in 2004 and 2011. Now, I wouldn't get hung up on it. Do you know what I mean? If you're going, oh no, oh my God, I can't believe, do you know what I mean? If you're going to spend the time that I suggest learning your 7 experiments, well, you won't care if it's 2 questions, right? It won't bother you. In fact, you'll be delighted because you've learned it, the 7 experiments for 1 question, and now you're getting 2 whole questions out of it. Couldn't be better. Do you know what I mean? But don't get too hung up on that. It's happened twice in 24 years. What do I think is going to come up in question 3 this year? Well, I've no idea, but the determination of relative molecular mass hasn't been up for a few years, so that's due a twist, as I said. Rates of reaction are always possible. Even 2 years in a row, rates of reaction, questions are possible. They like them. Colorimetry, water. They like water in question 3. Do you know what I mean? So something along that. Best way to study for question 4, practice, practice, practice. If you do 2 question 4s out of the last 24 years, you're going to go, this is impossible. There is no overlap. There's no pattern here. How am I going to, do you know what I mean? This is just seems completely random. If you did 10 question 4s from the last 24 years, pick 10 random question 4s, you'll see you've got your definitions, you've got your oxidation numbers, you've got your little bit organic. There's always going to be atomic theory. There's always going to be organic. There's always going to be a little bit of stoichiometry. All right. Last question now before I move on, and I'll come back to more questions again. All right. I promise at the end. In rates graphs, is the rate always going to be proportional to concentration? Yeah, that's the one that you're going to get the straight line. Right. The others don't give you a straight line graph. Do you know what I mean? From the origin. Right, concentration. If you increase the concentration, your rate is going to increase and it's going to be a straight line. All the other graphs are going to be curves, whether they curve upwards or curve downwards, like the temperature one, or sorry, from down going up, you know what I mean, in a kind of a dip way. Yeah, you're always going to, for concentration and rate, it's going to give you a straight line graph. Okay, so again, you think of any questions over the next, 30 minutes or so, feel free to type them in and I'll get around to as many of them as I possibly can at the end. But it's kind of, going to maybe do something that generally is required on a higher level paper, right? And that is a little bit of stoichiometry where you want to show that something is in excess. Also, maybe a little bit of how do I, or what way am I going to get information given to me and have to convert to moles? So maybe a little bit of stoichiometry. It's there every single year, every single year. What I meant by question 11 and the option is there's two options and you only study one. So your school, your teacher will have decided which one they want to study. So whether that is further industrial and atmospheric, which is the one I decide to study with my students, or whether it is more electrochemistry and more organic, which is the other option, that's somebody chooses it. You know, there's a two. You never study both of them. It's a waste of time because there's questions on each. So school chooses which one, the teacher usually chooses which one they're going to do, and that's what I mean by that. So I'm going to share my screen again with you folks, and we're going to look at a little bit of what to call it, stoichiometry here. So if you have calculators, you're very welcome. If you have calculators, then you can whip out the old calculators. If you have periodic tables, well, that'd be great too. I mean, you'd never turn up for something on chemistry without a periodic table. Sure you wouldn't? All right, okay. So if you have, I have one here anyway, I can throw on my screen to show you what I'm talking about. So I'm going to share my screen again with you folks. This time I'm going to be using a document reader, which hopefully everything will work very well for. So where is my visualizer and my document reader? So you are now looking at my pencil case, which is not what I wanted. So I need it to look downwards. So we should be able to see a page here, a piece of paper, and I just want to run through a little bit, a few things in terms of stoichiometry. I also have my exam papers here because, again, stoichiometry, you know, instills the fear of life in some people. I mean, you know, the minute it's mentioned, you know, they get that frightened bunny rabbit cotton headlights, do you know what I mean, look or whatever that's there. Okay, so I have a front page of an exam paper here. This happens to be 2022. All right, front page, and I have my maths tables, which is my periodic table, and I want it on page 79 actually. So I have this here. So I have access to all of this, right? Okay, on the day of my exam, the front page of the exam paper and the maths tables. And the thing about stoichiometry, or the calculation part, right, of chemistry, is that you don't have to memorize any numbers, right? Okay, you don't have to memorize any values, any amounts. They're all given to you. All the examiner wants to see is, do you know which numbers to use, and do you know how to use them? So you don't have to, you know, remember what molar volume at SGP is, or what molar volume at room temperature and pressure is, or what the relative atomic mass number is. You don't have to remember any of that. You look it up. It's all available to you on the exam, which is why I'm always fascinated when students don't look at the front page of exam papers and they're carrying out a question and they make up the wrong number themselves when everything is given to you. So what I want to show you here is how we're going to go about, do you know what I mean, doing a little bit of stoichiometry, a little bit of what you call it, conversion. Right, now, if you have a substance that's solid, and now this is just in general, if you have a solid substance, well, generally we deal with solid substances in mass, which means grams. We weigh them out. So if some substance is a solid substance in a question, you're not going to be measuring its volume or anything like that. You're going to be weighing it. And what we need to do is we need to change grams into moles. So we're going to get our grams, we're going to divide by the relative molecular or the relative atomic mass, and that's going to give us our moles. Now, relative atomic masses, front page of exam paper. Let's look, 2022. Look at it, tells you relative atomic masses rounded, and they give you a list of them. Now, they vary from year to year. So this is 2019. This one, they always have hydrogen, carbon, and oxygen in them. And then, depending on what comes up in the other questions, they'll have different elements. So, I mean, mercury came up in what you call it, 2019. So that was there, 2001. Now, if I wanted mercury, I could use my page 79 anyway. Here's mercury, but you see the relative atomic mass is 200.6. So this is why it says rounded. So the numbers are rounded on the front page of the exam paper. They're not on the actual page 79, but you are allowed, and that's what their marking scheme is going to work on the rounded up version. Two exceptions. We do not round chlorine. Chlorine, if it's in an exam paper, will be 35.5 on the front page of the exam paper, and copper will be 63.5. So they're the only two that they don't round off. Do I need to memorize those? No, they're going to be on the front page. So if I want to change grams into moles, I'm going to be using these relative atomic masses that are on the front page. So this says potassium 39. So, you know what I mean? So the relative atomic mass, front page, and periodic table. Relative molecular mass, we add the relative atomic masses from the formula. And 80% of the time we're given the formula. So, example, I want to change 4 grams of potassium into moles. I need to change 4 grams of potassium into moles. 4 grams divided by, off to the front page of the exam paper, 39, and work it out. So you're dividing your 4 by 39, and that is giving me 0.102564 moles. Now, I'd always go to 4 or 5 digits after the decimal point, whatever, you know what I mean, on my screen, right, just for accuracy, unless they tell me they want it rounded, do you know what I mean, off. If I want the relative molecular mass, so let's say I want to do 4 grams of calcium carbonate into moles. Well, now I have to go to the front page of the exam paper and find the molecular mass of calcium carbonate. So on the front page, calcium is 40, so there it is. And there's only one calcium in the formula, so that's 40. Carbon is 12 on the front page, there it is, add 12. And 3 oxygens, oxygen is 16 on the front page, so 3 times 16, and that all adds up to 100 when you add it together. So you get 4 grams and you divide by 100, and that's going to give you 0.04 moles. So if something is solid and it's measured in grams, we are going to change it into moles by dividing by what 1 mole of that substance would be, right? The mass, right, from the periodic table, right? If we have a gas at standard temperature and pressure, and note here, this is gas at standard temperature and pressure. So on the front page of the exam paper, we are told molar volume at STP is 22.4 litres. But just in case that's not enough, if we go to page 64 of our maths tables, we have molar volume in litres at standard temperature and pressure is 22.4, and they've said in litres. So that piece of information is in 2 places for me on the day of the exam. I'll probably just go to the front page for it. Now, what you have to remember is 22.4 litres, folks, is 22,400 centimetres cubed. Right? You must be able to deal with conversion of litres and centimetres cubed. Right? That kind of conversion is something that you do when you are in second class. So you're 8 years of age or thereabouts. Right? When you're in second class, you learn how to change centimetres cubed into litres or centimetres into metres and all of that. So you're multiplying by 1,000, but it's 22,400 centimetres cubed. And that's important because, again, if I have volume at STP, I'm going to divide by either 22.4 litres or I'm going to divide by 22,400 centimetres cubed to get moles. So when I want moles, I divide. I divide by whatever value it is that the question asks about. I am not going to be dividing volume by relative atomic mass. Relative atomic mass is for grams. That is all it is for. It is for mass, relative atomic mass. So it is when you're dealing with grams. This is volume at STP liters or centimeters cubed. So, for example, we have 240 centimeters cubed of oxygen gas at STP, and we want to know how many moles are in that. Now, 240, and have a look, it says centimeters cubed. So I am going to divide not by 22.4. 22.4, folks, was for liters. That's what 22.4 gave us, right? Okay. 22.4 has the letter L after it or the word liters after it. This is centimeters cubed, right? This is centimeters cubed. So we're going to divide by 22,400 centimeters cubed to get our moles, right? So and that's it. The calculator does the work. I'm getting the marks for knowing that centimeters cubed at STP, right, to use this number. This number that they've given me in liters in two places, right? The marks are going for me choosing the 22,400 to divide by, not the relative atomic or relative molecular mass. So 22,400. So what's that work out to be? 0.0107 moles. Okay, so 0.0107 moles. But if I'd been told 240 liters of oxygen at STP and I wanted the moles, well, this time it would be 240 litres divided by 22.4 litres because my units, are having to match. Students, do not spend, in my sweeping statement, which I tell people to avoid, but anyway, right, many students, I should say, do not give enough attention to units, folks. They just think that they're not important. Now, if units weren't important, then it wouldn't matter whether they gave me units in my question. And if you don't have units in the question, well, you're not going to be doing very many questions, all right? So the units are what tell you, the units tell you what it is that you're supposed to know. And I go on about units so much in school that I have students who bought me little presents, and that's one of them, because I was writing units so often. So I get fierce enjoyment out of bashing, what you call it, that around. And another one that I like, and somebody bought me, is for when you do balanced equations, you've got ratios. So I have another one for ratios. So soon I'll be teaching solely in just stamps and bashing them around on the paper. But the units are what tell you the number to use. When it says centimeters cubed at STP, it's going to be 22,400. When it says liters at STP, it's going to be 22.4. Now, every now and then, they don't go STP, okay? They will go room temperature and pressure, right? And, they don't make a big song and dance about it. You are expected to be able to read the question and it should be staring you in the face. So 2019, have a look here. We have our usual molar volume at STP, 22.4 litres, and then we have molar volume at room temperature and pressure, 24 litres. So they've given me the information I need. It's all there for me. It's a matter of using the correct number. So if it says room temperature and pressure and you use 22.4 litres, well, you're not going to get any marks because it means you did not read the question and you have not answered the question that you were asked. So if we had 240 litres of O2 at room temperature and pressure, and we wanted moles, well, now it's going to be 240 litres divided by 24 litres. And remember, that number does not have to be memorized. Right, I was getting my calculator out there for a second. That's terrible. So that's obviously 10 moles, folks, sorry. Right, but this does not have to be memorized, but you need to go to the front page and find it. All of the information you need, right, okay, is on the front page. So that's for gases, folks, right? So we had solids were measured in grams, we divided by the atomic or relative molecular mass. We had gases, could be at STP or RTP. And, you cannot use the number 22.4 unless you see STP in the question. And you cannot use the number 24 litres unless you see room temperature and pressure in the question, right? They are for those conditions of temperature and pressure and those conditions only. So next we're going to go on to liquids. Now, for liquids, folks, we can have the following. Pure liquids, right? Pure liquids, meaning like ethanol is a pure liquid. What I mean there by pure liquid is I haven't mixed it in with another liquid like water. It's not a solution. It's just one substance that is liquid at room temperature. It exists as liquid. Like water is a liquid. Now, pure, it's got loads of things dissolved in it, but it exists as liquid at room temperature. So with pure liquids, folks, here's what you expect to be given, right? This is what you expect. This is, I wish I had this, do you know what I mean, gone into my leaving cert, because I had to figure all this out for myself. Do you know what I mean? I was going, why do I get grams sometimes and I get volume other times, and I get volume at STP other times, and I get volume and density other times? Volume and density. So if I'm dealing with a pure liquid and I want to change that into moles, because ultimately that's what I'm doing 99.999% of the time, is taking information given and converting it into moles. All right, okay, so expect to get volume and density. So if we were told, how many moles in, and we'll go, 14 centimeters cubed of ethanol, C2H5OH, right, whose density is 0.8 grams per centimeter cubed. So there's your question. So we expect volume and density when we are dealing with pure liquids, right? Because look at this. Ethanol is not a gas at room temperature and pressure. Ethanol is not a gas at STP. Ethanol is a liquid under those conditions. So we can't use 22.4 and 24 litres, because remember, they are for gases and for gases only. So how do we change a liquid that is pure into moles? Well, they have to give us the density. Without the density, I can't do it. And again, I am very much into units. Have a look at the units for density. They're telling you that for every centimetre cubed of ethanol, there is 0.8 grams. For every 1 centimetre cubed of ethanol, there is 0.8 grams. Like, it is 0.8 grams of ethanol. And I've got 14 centimetres cubed. So 1 centimetre cubed is 0.8, 2 centimetres cubed would be 2 times 0.8, 3 centimetres cubed would be 3 times 0.8. So obviously 14 centimetres cubed is 14 times 0.8. Because mass, folks, grams, is equal to density multiplied by volume. Mass is density times volume. And if we didn't know that from junior cert, we need to know it now. So what am I going to do? I'm going to go, the mass is the density, 0.8 grams per centimetre cubed, multiplied by the volume, which is 14 centimetres cubed. So with both the old calculator, 0.8 multiplied by 14 gives me 11.2. So that's 11.2 what? Grams. Have a look at that now. Right, okay, that's 11.2 grams. I was asked for moles, but that's grams. Now, if you're one of these people, and there are many around, that just writes numbers and doesn't put units after it, you might be thinking 0.8 times 14 is 11.2 moles, and you might think, I've done that now, and you'll use 11.2 for the rest of the question, and everything will be absolutely wrong, and you will get no marks, and you'll be complaining and going, but all my maths were right, and I'll be there going, look at what's on the front page of the exam paper. It doesn't say maths, it says chemistry. And if you can't keep track of your units, then that means your chemistry is not going to be correct. This is not a maths exam. You are not getting marks for add, subtracting, multiplying, and dividing. They expect you to be able to do that. It's that you can keep track of the numbers. What are they? Are they moles? Are they mass? Are they grams? Are they this? Are they that? Your job is to keep track of that. So now that we have the grams, well, How do we change grams into moles? We need the molecular mass of ethanol from the formula. So that's when I'd be going back to the front page of the exam paper and I'd be looking up carbon and it'd be 12. So that's 2 times 12. Hydrogen, 5 times 1, 16 and 1, which is 46. So it's going to be 11.2 grams divided by 46 and we get our answer in moles. So if the substance is a pure liquid, 0.2434 moles. If the substance is a pure liquid, expect volume and density. So another one that you'd get for pure liquid now would be what do you call it? Benzalcohol or phenylmethanol, right? In your preparation for benzoic acid, right? So in that particular question 2, you might have to change volume and density, do you know what I mean, into moles. Or another one, if you want to note it, would be if you're extracting clove oil from cloves in question 2, you get your clove oil in centimeters cubed. They might give you the density of the clove oil and get you to work out what mass of clove oil, do you know what I mean, you got. So that idea of a pure liquid with density and volume is something that can pop up, especially what you call it in question 2, but not solely for question 2. Then the other kind of liquids we have are solutions. Now this, folks, is absolutely 100% going to be on your paper. Concentrations of solutions. And concentration of a solution is the amount of solute per amount, put that down a little bit, sorry, of solution. And what I want you all to notice, and because we're restricted on time, I'm only going to kind of say this a couple of times. I bash on about this constantly in class. The two things you need to know is amount of solute and amount of solution. Solute and solution. Number 1, the amount of solute. Number 2, the amount of solution. And if you know both of those, you know the concentration. Right? Okay, usually. Unless it's a secondary standard and then you have to do a titration, but that's another day's work. All right? So amount of solute and amount of solution. And what I want you to notice is you do not give any interest or any notice whatsoever of the amount of solvent. You need a solvent to prepare a solution. Solutions are made up of 2 parts, but if it's the concentration of a solution, it's the amount of solute and amount of solution. So for example, here's a container that says 100 centimeters cubed. It's got this solute in it, which would be dissolved, folks, but I'm just kind of showing little drops. So let's say that this here is sodium carbonate and hydrosodium carbonate, and let's say there are 3.2 grams of it there. And let's say that I had used water, and the water that I used was, let's say, 97.6 centimeters cubed. Well, you know, looking at all of these, that's the solution. That's what the solute and the water together gave you. Water is the solvent. So I've got my, sorry, that should say solute. There we go. So I've got my solution amount, I've got my solute amount, I've got my solvent amount. That I do not care about. The amount of solvent is irrelevant. If I want to express the concentration now of that solution, it is going to be 3.2 grams per 100 centimeters cubed. That is a concentration, right? That is a concentration. Now, you know, how is it a concentration? People go, but don't you have to have it in moles per litre? Well, I can change it into moles per litre, but moles per litre is just a particular unit of concentration that is used quite often and is important, but that itself, folks, is the concentration of a solution, right? Those, you know, here is your amount of solute. That's number 1. Here's your amount of solution, the 2 together. That's number 2. That is the concentration of that solution. Now, we do have particular units of concentration that we need to know. So we have this capital M, which is called molarity. But folks, again, I'll get people and I'll go, what's that? And they'll go, molarity. And I'll go, what's that? And they'll shrug their shoulders at me and they go, I don't know. And like, that is a waste of your time learning M. Capital M stands for molarity, but you don't know what molarity means. So molarity is moles of solute per litre of solution, or it is moles of solute per 1,000 centimeters cubed of solution. It's either of those. It's either moles per litre or moles per thousand. That's what molarity is. So that's your solute bit, number one, and that's your solution part, number two. So that is a way of expressing concentration. If somebody said to me, I have a 0.02 molar solution of potassium manganate 7, what that means is there's 0.02 moles of KMnO4, the solute, in 1,000 centimeters cubed or litre of solution. So what we're saying is if I poured out 1,000 centimeters cubed, or if I poured out a litre, there'd be 0.2 moles of the solute. Chances are we're not going to be pouring out a litre of a solution. When we do a titration, for example, we might find that 16.2 centimeters cubed of a 0.02 molar solution, KMnO4, came out of the burette in a titration. So in a question 1, right, came out of the burette. So what we want to know is moles in the amount reacted. And the amount reacted is the amount that came out of the burette. So this would be like, when you're adding your potassium manganate 7 from your burette into your conical flask. So what does this mean? Everything hinges on me understanding what does this mean. It means 0.02 moles of KMnO4 in 1,000 centimeters cubed. That's what it means. But you see, I didn't pour 1,000 centimeters cubed out. I poured 16.2 out. So how do I deal with that? Well, I take my 0.02 moles and I divide it by 1,000. Now, why am I doing that? Well, to find out how many moles would be in 1 centimeter cubed. Right? If there's 0.02 in 1,000, well then divide 0.02 by 1,000 and see what's in 1 centimeter cubed and multiply it by the volume that we did pour out, which in this case, and I am picking random numbers off the top of my head, is 16.2. So you take your 0.02, you divide by 1,000, you multiply the answer you get by 16.2, and I am getting 3.24 by 10 to the minus 4, what? Moles in what? In 16.2 centimeters cubed. Now you can change that number. Pick any number you like. Pick any number you like for the volume. Change that to any concentration you like. If it says capital M, if it says molarity, you are looking at moles in 1,000 centimeters cubed. End of. That's what you're going to be looking at. So that's how we deal with solutions. I mean, if they had said to me, like in 1 year, there was 1.2 grams of NaOH in 500 centimeters cubed, and I want to know moles in, we'll say, 25 centimeters cubed. So there's my solute, there's my solution. So what am I going to do? 1.2 grams in 500. So let's divide it by 500. Why would I do that? To find the grams in 1 centimeter cubed. Because if there's 1.2 in 500, I divide by 500, and now I've got the grams in 1 centimeter cubed multiplied by the 25 centimeters cubed that I actually poured out. So that now is giving me 0.06. But you see, here's where this comes into it. Right? Is the answer, right? I wanted the moles. That's what I was looking for. Is this moles? No, this is grams in 25. And I want to know the moles in 25. So now I got to go back and find, front page of the exam paper, sodium 23, oxygen 16, hydrogen 1, adds up to 40. So 0.06 grams divided by 40. Now I'm getting the moles. And again, I am keeping track of my units. I am not just writing random numbers and forgetting what they are actually measuring. So that would be moles in 25 centimeters cubed. And again, something like that would be quite relevant in question 1. Now, I can talk forever, and obviously you're here to ask questions. So we're back onto our question time, folks. So I'm going to stop presenting, and you guys, from me on, and oops, a daisy. Hopefully I don't knock you off now. You guys can go questions. So we've done the rates and we've done the other thing. Any more questions, folks? Type away. Anything at all you want to ask me. I stay here for the next 10-15 minutes to answer questions. If you didn't put centimeters cubed at the end of your answer, how many marks would you lose? Do you know what, Grace, I think your name is? Absolutely nothing, right? Nothing in terms of the marking schemes in current years. Now, if I had my way, I mean, I'd be taking everything off you, but you will not lose marks. But the thing is that, you know, if you're coming down through a calculation and you're working out centimeters cubed, and you want to do the next part of the calculation, but you don't know that the number is centimeters cubed, you know, at STP, well, you won't know what to do with that number. Do you know what I mean? So by keeping track of units, the units tell you what numbers you're going to use. When you see grams, you know you're going to use relative atomic mass numbers. Do you know what I mean? When you see volume at STP, you're going to know that you use 22.4. But I mean, if I said to you, how many moles in 5 of calcium carbonate? And you'll go, what? And I go, how many moles in 5 of calcium carbonate? And you go, but I can't do that. And I'll be going, why not? And you'll go, because you haven't told me, is it 5 grams? Is it 5, you know, centimeters cubed? Is it 5 molecules? Is it 5 atoms? Is it 5? So you see, units are the answer to the question. They're the very things that alert you to what you need to use. So Grace, not putting in centimeters cubed in an answer, as long as your answer is right, is not going to do anything in terms of your marking scheme. But it might be something that might, you know, cause you to lose marks if you don't know it's centimeters cubed. Easter, would I recommend A or B if you struggle with organic and water? You did February, so would there be repeats of classes? I try, and as far as I'm aware, I manage to do different things in every revision course, more or less, from the August course all the way up to Easter. I try to do different topics, different areas. So what you call it, the organic part, I think, is in B, but I mean, you'll have to check that out now. Don't take my word for it. But you know, kind of in a revision course, there's only so much organic we can do. So you know, we will do as I'll be doing as much as I can and giving as much advice. Do you know what I mean? As I can. Studying chemistry every week. You know, how long is a piece of string? I would be saying you should be doing a minimum of 3 hours. Okay, that's what I'd be saying, a minimum of 3 hours. And at this stage for you guys, like an hour would be kind of just doing whatever you're doing in school, like, you know, maybe if you've homework to do or something like that. The majority of my study now, from now until my exam, is exam questions and marking schemes. That's what I would be doing. So I'd pick a topic, I would have a method, not this jumping around. Pick a topic, all right, okay, and stick to it and practice. I'm going to do, you know, I'm going to do my volumetric analysis. I'm going to do my organic experiments. I'm going to do question 6. I'm going to do the general organic chemistry question. Do you know what I mean? Those ones that I really, really would advise you put time and effort into. And then I'm going to do equilibrium, water, and rates. And I now have a H3. That's a H3 worth, possibly a H2 worth. You know what I mean? You know, depending on the year. But that's what I would have, a plan of action. It's too much to think about all of it, so you subdivide it up and you get things done. All right, that's what I would, do you know what I mean, what I would be doing. Your teacher isn't planning on doing either of the topics. We're going, but you put the resources up. Is it worth it to study it? Do you know, if I was struggling with chemistry, it is a guaranteed 31 marks, right? Okay, So, there's that. If I was not struggling with chemistry, I would tend to spend more time at those other areas that I've said. So, if you're a good chemistry student, if you're doing reasonably well, I'd put more time into the volumetric, the organic, do you know what I mean? And the equilibrium rates, water kind of atomic theory area, and forget the option. I don't want to lose one moment's sleep over it. Do you know what I mean? Because it is last part of question 4, and so you'll still be able to answer 8 out of 11 instead of 8 out of 12. And it's part D of question 11, and question 11 has A, B, and C, and you only have to choose 2. So you can still have a choice within question 11. So I wouldn't worry about that. Do you know what I mean? At all. All right, with the options. Okay. What questions do elimination, addition, and all of that come up on? Lucy, that would be your general organic chemistry question mainly. Right. That's the one where they go, I want to change a primary alcohol into an aldehyde. How do I do it? Oxidation. What reagents do I use? Sodium dichromate with sulfuric acid. How do I change an alkane into a chloroalkane? Free radical substitution. What reagent do I use? Chlorine. What condition? UV light. So mainly, now I'm not saying only, but mainly you need to know your reaction types for the general question 8 or 9 on organic, and your preparation of ethene is elimination reaction, preparation of soap is called base hydrolysis, and preparation of benzoic acid is oxidation. So those, you'd need to know those reaction types for that as well, Lucy. Farouk, we have, if my class is not answering question 10, the choice being it, or should I go off and study myself, or it's better to focus on the others. Now, the industrial and electro would be question 11, part D, not question 10. Question 10 doesn't have the choice part in it. If you're not doing electrochemistry has, as like the main part of the syllabus, electrochemistry has only ever been half a question, or there is a mandatory experiment, so it can pop up in question 3. But remember, you're going to be preparing question 1 and 2 within an inch of your life. So what comes up in question 3 isn't really going to matter that much, do you know what I mean, to you, because you're going to prepare question 1, question 2, you're going to practice your question 4, you're going to do your atomic theory, your question 5, you're going to know your question 6, fuels, heats of reaction, you're going to know your general organic. So that's 6 questions, and you've only 2 more to pick, and it won't matter that you won't know question 3. So, there's always a way, folks. Don't worry about that. What is next? pH questions. Where did I go for that? Here we go. pH questions, would you, now pH graph isn't guaranteed to come up, I mean, there have been 1, 2, 3 pH, three that they've given you results for that you've had to plot on graph paper, and twice that you've had to sketch. Do you know what I mean? So whether you get the S shape or the Z shape for those pH curves, definitely not, do you know what I mean, guaranteed. You will be able to access the recordings of the class. The office, I'm sure, will be able to tell you about oh, you think somebody else is answering for you. It's going to be gone. Should you study by topic or question? I'd go by question now at this stage. I'd be preparing by question. Yeah, you know what I mean? It's more focused, you know what I mean, at this point, and the question and the marking schemes. The question and the marking scheme, you can have your book, you can have your notes for reference. If something in the marking scheme doesn't make sense to you, I would be, checking out what it said in my book, do you know what I mean, or my notes that my teacher gave me. That would be for reference, for understanding. But essentially, you want to know you want to know the wording that they're looking for, and that's part and parcel. You can learn all the chemistry under the sun, right? Okay, you can spend hours and hours and hours at it. The main thing is, how are they going to examine me in this? How are they going to word a question on this topic? Do you know what I mean? Because they're never going to say, tell me everything you know about organic. Do you know what I mean? So how are you going to know? If you haven't started equilibrium in school, right? If you haven't started chemical equilibrium in school, would you recommend to start learning them now? But there's still loads of time. Like, I mean, I still have one of the groups I teach in school, I teach in 1 year. Do you know what I mean? And I still have about 6 or 7 chapters left to do with them. And I'm not a bit bothered. I'm not a bit worried. Do you know what I mean? I'm going to, do you know what I mean? Get that done. So trying to study chemical equilibrium on your own is a little bit difficult. It's not a difficult chapter, but you need a bit of guidance with it. So no, you know, if your teacher is going to cover the stuff, right? Okay, the material, then you know it will get covered, even if it gets done the last week of school. As long as it gets done, that's what's important. I'd be more, do you know what I mean, into, you know, do I know what I'm supposed to know already? Right? Okay. Is it that, you know, do I know what it is that I'm supposed to have information about? Do you know what I mean? Already. That's what I would suggest. With you there. What separates a H3 from a H1? A H1 knows everything. A H1 student is going to be able to answer everything. They have put so much time and effort into it. Do you know what I mean? And they've practiced so many exam questions. I mean, I get students, you know, towards the end of the year, and they tell me what the marking scheme answer is. They're the ones I might say, do you know what I mean, such and there was such and such a year where they didn't accept that, and they're able to, do you know what I mean, they're able to tell me. It's reasonably, Keelan, I think is the name there, it is reasonably with a decent amount of work because of the choice that's in the question, and you put, do you know what I mean, the effort into those questions that you can have prepped in advance. It's reasonably easy to get a H3. Do you know what I mean? But like a H3 is 70%, right? Up to 79. So let's say a H3 is 70. A H1 is 90. So you're talking about, you know, a whole 20%. That's 1.5 questions in the difference of knowledge. Do you know what I mean? In the difference. And this is chemistry. Chemistry is all black and white. There is no room for the gray areas. And this is why I'm saying to you, the, you know, getting the, what you call it, the getting everything, do you know what I mean, sorted in terms of, you know, looking at your marking schemes and seeing exactly what it is that they're looking for. Should schools be finished the course by now? I've one chapter left to do with the group that I've had over 2 years, but we have spent most of sixth year half and half, revision new, revision new. But you know, like, don't worry about that. Should they be? Yeah, maybe yes. But if you're not, there's still time to finish, so I wouldn't be too worried about that. Electron configurations, no, generally question 5, Naomi, or your atomic theory that comes up in question 10 or 11. There's always a half a question in that, so it could pop up there. But generally question 5, where you're going to be writing your electron configurations and being able to figure out how many energy levels, sublevels, orbitals, all of that. Remember, an energy level is like 1, 2, 3, 4. A sublevel is 1s, 2s, 3d, 4p. An orbital, well, s's are both orbitals and sublevels. So 1s is an orbital, 1s is also a sublevel. It's 2 in 1. But 2p is a sublevel, 2px is an orbital. 3p is a sublevel, but 3py is an orbital. So what's very important is that you're able to write those configurations and count how many energy levels, sublevels, and orbitals. They love asking you that. Do I recommend sitting full-length exams in practice? I recommend that you practice exam questions while you're studying. That's what I would be recommending. Maybe some stage over the Easter holidays, you might grab maybe one of them. Maybe you haven't looked at any of the deferred papers there from 2022 or 2023. Maybe you don't know, you're not familiar with those exam papers. So maybe pick one of those guys and say, I'm going to try this. I'll sit down, I'll set 3 hours aside and see how I get on and use my marking scheme. Do you know what I mean, to do it? But, you know, if you've done a mock, you now know the timing. Do you know what I mean? You're looking at 22.5 minutes per question, folks, on your Leaving Cert paper, 22.5 minutes per question. And that's read it, do it, and read over it. Now, if you have those questions prepped, like I've suggested, timing will never be an issue. Never. And I wouldn't be aiming to get more than 8 questions done, right? Okay, because it is unlikely that if you decide to do a 9th or 10th question, it is unlikely that you would, you do better because you'd have chosen that question in the first place. That's the other thing. Somebody else came up there with question 4 as well. You see, absolutely right. Sometimes you remember things more than I do, which is super. What was the other thing I was going to say to you? It's unlikely to, if you did an extra question, oh, it's gone out of my head, it'll come back into my head again. The timing is 22.5 minutes. Yes, this is the thing that I was going to come in. Go into the exam and read every question, right? Every question. Because you cannot choose your best 8 if you do not know what choice is out there. Do not go into the exam and dive into a question and say, oh, I'm definitely doing question 2. I mean, you might read all the way through the exam paper and decide that there's another question that you're going to be better at than question 2. And while you might have prepped that, you know, sometimes this happens. You read everything. You cannot choose your best 8 questions unless you know what's on choice. And so would I then, I wouldn't recommend. I mean, if you're a fantastic chemistry student and you find that you've finished 8 questions and you've gone over them and you're really happy with them and you're going to stay in the exam the full 3 hours, which every single person should do not leave, even though every cell in your body is going to be screaming to get out by the time you get to chemistry. You force yourself to stay there for that extra 15 minutes or whatever. Then I might, Saif, then I might decide, Asher, do you know what I mean? I'll go at another question. But my aim is to choose the 8 best out of what's on offer and to think about what I'm writing. You know, I gave mock there to my crowd and I've warned them now so many times about this. And some of these students now are really top class students. And I asked them to name the reagent and the catalyst used in it. It happened to be a reduction reaction in organic chemistry. And I have people writing down H2 and Ni. Now, H2 is not a name. H2 is a formula for hydrogen. They were supposed to write the word hydrogen because I specifically said name, and they're supposed to write the word nickel because I wanted them to name the reagent and the catalyst. In another question, I wanted the chemical formula for the drying agent used in the isolation of clove oil from the clove oil emulsion. Do you know what I mean? In the solvent. I wanted the formula for it, which was Na2SO4 and hydrosodium sulfate. But again, I got students and they wrote for me the name. They wrote anhydrosodium sulfate. Like they know the answer, but they were told write the formula and they wrote the name. Do you know what I mean? So please, rather than rushing through and trying to get a 9th question or a 10th question done, you know, you'd have chosen that 9th question as one of your first 8 if you'd really liked it in the first place. If you had, you know, gone and approached the exam by reading everything to see what was on offer. Okay, time for, we say, one more question. And if we don't have one, sure, that's okay. Right. I'm going to be doing the Easter revision course inside in the Institute. I also do a few TikToks for the Institute, and there's going to be, if you're following me on TikTok, there's going to be a free masterclass coming up on question 6 on the paper in about 2 weeks' time, folks. So, you know, you can sign up for that, and I'll be focusing in on just question 6. So anybody else, any other question that they want to ask? We're good? Okay, listen to me, guys. Thanks for tuning in. There was a mix up in terms of times this morning, so hopefully, you weren't waiting too long this morning, all right, for that. It was really, really good to offer you some advice, and I hope that you find it helpful. Lots of thank yous coming in, and I really appreciate that, folks. But I hope that what I've said to you, you found helpful, and that's the most important thing. And remember, you know more chemistry than you think you know. So a little bit of focused approach, do you know what I mean? A little bit of, you know, belief in yourself, bit of practice will get that belief, get that confidence going, and you'll knock it out of the park, folks, come June. So I might be talking to you. You might see me online or in person between now and the exams. But if not, best of luck. But yeah, just keep at it, folks. You know, it'll all turn out great in the end. Okay. Thanks a million. Bye-bye now. Bye.